That would be really funny.
Come on. I got plenty of those as it is. I don't need to put it all together. Okay. Today, I want to go through a couple different types of factoring. That's it. No homework today. It's kind of an easy day. I just want to continue on the idea of like where we're at. Because yesterday I gave you those 5 problems at the beginning just to see where you're sitting. It's not a quiz. It wasn't anything like that. I just want to see where you were and kind of where we can get to by Monday. Monday, just to let you know, I will not be here Monday. I'm gone that day. You'll have just some homework to work on from the stuff we work on here. It's basically just a work day. Mr. Greiman is your instructor that day. He might actually go through a couple examples because he knows it probably better than most teachers in this building. So he'll go through a couple examples and then he'll turn you loose and you have plenty of time to work.
I think we're going from first to third period though.
Juniors are?
Yeah.
Never mind. So it'll be Tuesday if you're back. Okay? No worries. I just planned that you guys are here in case something goes wrong. That's all I always plan for. All right. So no worries if you're not here. We'll just move on. All right. Hey, here we go. The types of factoring that we talked about yesterday, and I'm going to go through an example of each type. All right. So number 1. First type of factoring. We had common factors. Now, we talked about that yesterday. You should always do common factors first, no matter what. It should be the first go-to type of factoring you go through. In fact, I'm going to do an example of it right now. That way you get to see what you should do when you look at a problem. So, here we go. Let's go with 128 x to the third minus 50x. Let's say that that's your problem. So you first look at it and you're like, okay, well I know for a fact they both have x's. They both have 2's, at least a 2. I know that by just looking at them because they're even numbers. So by seeing that, I know that I got to do common factors first when I look at that problem. So the first thing you got to do, you got to pull that variable out. So I'm going to pull the x out, I'm going to pull a 2 out for sure. Now if we need to pull anything more, because maybe I just see that there's a 2 for sure. I don't know if there's a 4 or anything like that. So I'm going to go with the 2 idea. 128 divided by 2 is 64. I took out 1x, so there's 2 x's left over. We have a minus sign, and then I'm going to take out a 2 from here, that's 25, and an x. Now, took out the x, sorry. All right, so I took out the x, and I took out a 2. Now, the 25, the only thing that goes into 25s are 5s, and I know 64 doesn't have a 5 in it. So we've taken out the greatest common factor, it was a 2. Now, that right there, you just did it, that's common factors. Just look at what they have, write down what's left over. Now, if you need to go further, like in that parenthesis, that would be a different rule. Because maybe this part here can just split up further, and you just leave the 2x out front. Okay, those are the different rules that we're going to see here. Does that make sense what common factors is? Okay, question.
Like what field of a job would you have to be in to use, like what would I need to factor?
Factors anytime it's data analysis. So the main purpose, and this is something we're going to look at later, the main purpose of factoring, the whole point of it is to look at, like if you look at data, right, and you're looking at a graph of all this like information for your business, you're looking at where it hits the x-axis. That's literally what we use factoring for, is to figure out an x-intercept. Where do they hit different x's along the way? Because in data, like let's say you're doing a business, you're looking at all your sales, right? I want to know when did I hit zeros? When did I hit like non-profit versus like losses? Just right there in the middle. That's what we use it for. Okay. So most people probably wouldn't, they just type it in or they just look at the data on a graph and go, okay, these are the main ones. But that's like the reason, if you actually had a formula that represented your data. Okay, now, here's the idea. That's easy. It's very simple, you're just looking at it, if they have multiple letters, fine, pull those out. The one problem for common factors that always gets people, it's the number 1 problem, it's something like this. 12x squared minus 4. Let's say that that's my example. Now I could go more, but right there. Okay. So, on that problem, what's your common factor?
4.
A 4. People will pull out the 4, they'll get it wrong. It's an easy number, right? You're seeing it. It's a 4. You know 12 and 4 have a 4 in it. The idea is that when you pull out that common factor, you have to make sure that the item in this parenthesis is the same size as what you started with.
So put a 1.
Yeah, put a 1 in the back. That's what most people forget. Because this item in the parenthesis has to be a binomial like the thing you started with. So when I pull out the 4 here, this is a 3x squared. And in the back, the 4, I'm dividing the 4 out. There's a 1 back there. Because you're dividing the 4 off of it. It just doesn't disappear. There is a 1, like we said. It's one of those things that it gets people. It's just one of those things you just forget that it's still there. So just remember, common factors, anytime you pull them out, whatever the item that you started with, so let's say it's a polynomial where it's like 9 different items. There should be 9 items in here, even though you pull out a common factor. Does that make sense? For mine, it was a binomial. It started with 2 items, so I know there's 2 items still left in the parentheses. Now, if you're not sure if like you did it right, here's the thing. Just multiply it back in and see if it comes back with the original thing you started with. That's how you can double check to see if you did it right. You don't need to look at Slater. You don't need to look at the back of the book. Just multiply it together. Did it turn out to be the original thing you started with? That's a double check. Questions with common factors, though. Now, obviously, with both of those problems, even the first one, this one right here, this one, I can still keep going, which is really weird to think about. Those problems go further because of the way I set them up. We're going to look at those later. Those are my 2 examples that I'm going to pull when we get to like the 3rd category. All right, questions with the 2. Does somebody have those written down though, those 2 examples? Because I'm going to ask for those again because I want to continue those later. All right, let's move on. All right, let's do the trinomial rule now. Now, yesterday I talked about that there's 3 types of trinomials. It basically comes down to, I'm just going to make a very generic look here. Here's one, because it has a plus sign in the back, and there's a plus sign ahead of it. The other one, there is a plus sign. Alright, there's a plus sign in the front. Or sorry, there's a plus sign in the back. There's a plus sign in the back and a minus sign in the front. That's the second rule. And then the third rule is where there's a minus sign in the back. I don't care what's in front of it, it's just the minus signs in the back. That's the third rule. These are the 3 types of trinomials that we would normally attempt. If they're factorable. Because obviously, not every type of trinomial can go further, right? All right, so let's work on these 3. Then what I'm going to do is I'm going to give you a couple examples from here, because these are the ones we need to spend the most time on. We're going to do maybe 2 more examples after this, where I'm going to put numbers in the front, the leading coefficient in front of x squared, because that makes these problems significantly more challenging. Because you have to like really think about the numbers that are involved. Like these are very easy problems, not because of the numbers, but because there's no number out front of x squared. So it makes it a lot easier to actually attempt these. Okay, does everyone understand the 3 we're going to attempt? Okay, so let's walk through the first one here. We're going to go 2 parentheses.
So what is the answer?
11.
Okay, so first parenthesis. Okay, in these parentheses, this symbol, the plus sign in the back is telling me that these operations in here are going to be the same operation. That's what the plus sign that I circled. They're the same. What they are is they're both plus signs. This symbol right here is what they are. The plus sign in the back tells me they're the same. That's my little rule that I've learned. Now that we know that they're both plus signs, now we're going to break up the x squared evenly. The x squared is the front item. So that goes here and here in the front. The next thing we're going to break up is the back number. We break up the 2. The 2, there's only one group of factors for 2. It's 2 and 1. And what I have to make sure of is since they're the same symbol, plus and plus, these are going to add to make the middle number. Do they add to make the 3 in the middle? Yes, they do. It's very easy. Again, what makes this problem easy, there's no number out front. If I put a number in front of x squared, this problem's significantly harder now. And there's no shortcut for me telling you. It's literally guessing and checking numbers until it just works or it doesn't. Okay, are we good so far? Let's go to the second type of problem now. The second type, there's a plus sign in the back. So that means they're the same in here, they're the same operation. And what they are is they're both negative signs. This symbol in the front tells me what they are. They're the same, they're both negative signs. That's just how I read it. So since they're the same operation in here, these numbers are going to add to make the 4 in the middle. Just like this one. They're the same operation, they add to make the 3. That's just how I think of it. So break up the x squared, that's x and x. Break up the 3, well 3 and 1, that's the only option I have. And that does add to make the 4 in the middle. So they're both negatives, but they make the negative 4. Okay, questions at all about the second one? Third one, now this one has more options because I picked a bigger number, I picked 12. We picked 2 parentheses. Now the minus sign in the back is automatically, it's a negative, right? It's a minus sign in the back. They're automatically different, right? So that symbol just tells me that these operations are different. So it's automatically plus minus or minus plus. I don't really care which one you put. They're automatically different because of the negative sign in the back. So we break up the x squared. Well, the x squared broken up is x and x, that's pretty easy. Now we have to break up 12. The 12 has different options. 1 and 12, 2 and 6, 3 and 4. Okay, we gotta pick numbers that will subtract to make the 1 in the middle. Why we're subtracting? They're opposite symbols, plus minus. They have to subtract now to make the negative 1. It matters where you put the numbers in this case. Because the minus sign, it does matter. So in my case, I'm gonna go positive 3, negative 4. That way it makes the negative 1 in the middle. Again, you're always breaking up the back number and the front number. That's how you think of it. So if you're guessing, just pick numbers and then just put them in there and see if it works. Because literally, like when we get to these tougher problems, I don't have a rule. There's no magic thing I can tell you that always works. It's literally guessing and checking until you find numbers that just factor apart, if possible. Okay, we good with the 3 rules. I'm going to go 2 more of these, where I'm going to put a number in the front and make them significantly more challenging. Okay?
You don't have to.
Oh, we have to. Okay, all right. Do we have these written now? Are we good?
Mm-hmm.
Okay. All right. I'll leave that last one up there because I know some people like to write it. All right, let's do a couple examples here. First one. 5x squared minus 27x plus 10. What makes this problem challenging? Now, I picked an easier one here, but what makes this challenging is that the 5 and the 10 are both going to be used to make the 27 in the middle if possible. It's not just a random, thrown in there. We have to try to make 27 from the 5 and 10. Obviously just 10 alone won't make 27, but using the 5 and with it will. So we still do the same rules. My plus on the back tells me my operations in both parentheses are going to be the same symbol in here. That's what the plus sign tells me. In fact, they're both negatives. Why they're both negatives? It's literally right there. That's telling me what my symbols are. So I'm still following the same rules. Now, breaking up the 5x squared, I'm going to go 5x and 1x. I might have to switch these later. Maybe I have to switch their spots. Or if I had a bigger number, I might have to try different combinations of numbers. Now 5 is easy, like you can't change 5. Okay, for 10 has options. We have 10 and 1 or 2 and 5. Now, it will matter where you put them. Anytime there's a number out front, it does matter where the numbers go. Let's go 2 and 5 route, and I'm going to put the 5 in the back. So I'm going to go 2 here and 5 there. Now, the reason why I'm trying that first, I always pick the easiest numbers first. That's literally what I do. So if I'm like using the number 4, I go 2 and 2. If I'm doing the number 9, I try 3 and 3 first. If I'm doing 18, I'll try 2 and 9 or 3 and 6. I just pick one of like the ones where I break them up. And I just throw them in there. And what you do is, once you've thrown your numbers in there, you FOIL it back out in your head and see, does it make the 27? That's literally what I'm doing. I don't have that magic rule. You're literally just checking, are those the right numbers? Some people are really good at this. They can just see it in their head. Like they can just see the numbers that makes 27. But some people need to actually FOIL. So first is 5x squared. Outer is a negative 25x, because that's 5 times 5. In the middle, I have a negative 2x, because a 2 times 1, negative 2 times and then 2 times 2 is a positive 10. This does make the negative 27. So I put them in the right spots. Again, that part in the bottom is something I just do in my head. You don't have to do that. I just like to check, am I making 27? Because if I didn't, I'd go back to the drawing board. Because if I would have accidentally switched the 2 and 5 around, I would have made 15, not 27. If I would have switched the 2 and 5 in those locations. Because if I would have switched these, this would have been 5 times 2, which would have been 10, and then 5 times 1, which is 5, so it would have made 15 in the middle, not 27. So like you can make different combinations. Okay, last example for trinomial. Now we're going to throw this all together, and I'm going to make it kind of more difficult. All right. X squared minus 5xy minus 24y squared. Okay, notice, did I put a number out front? Makes it a lot easier. Drop the number. What makes this one difficult looking, I have multiple letters everywhere. It's still a trinomial. It doesn't have common factors. You can tell, like, not everything has an x or everything has a y. So, I'm going to do this by normal trinomial rule. That's what I'm going to do, and hopefully it foils out to make the right number. So I'm going to try the 2 parentheses. 2 parentheses. The back symbol is a minus, so it's automatically plus minus. I know they're opposites. This is the minus sign in the back, tells me it's plus minus. I'm going to break up the x squared now. So breaking up the x squared, I have x and x. Well, that's easy enough. You always break up the front number. The back number, now I have to think about numbers that multiply to give me 24. So I have one. So, say it again. 6 and 4, 3 and 8, 2 and 12. It's probably 3 and 8. Now, why 3 and 8? 3 and 8 differ by 5. Because if I put them in here, I am subtracting these numbers, and that's making the 5. Because they're opposites, so that's why I know I'm subtracting. I don't have to worry about the numbers out front, because that would be even more complicated. But throwing these numbers in here for 24, I'm going to go the 3 and 8 route, and I'm going to make the 8 negative. That way, and I need to put y's on. Because it's actually 24y squared, so I go y and 1. So now when you FOIL, that's where the xy comes from, because each of those have an x and a y on it now. X squared, negative 8xy, positive 3xy, that makes negative 5, and then a negative 24y squared. So you just break the y's. Okay, do we understand how multiple letters work? Okay, I thought it was just something we probably should see. It's something that you don't really see too often out of the 2 classes.
You know you have a note under your desk?
What?
You know that you have a note tape under your desk?
Probably. Who's it from?
I didn't know it was personal, so I didn't read it.
Let's try the masters.
Alright, I'll read it if you want.
Out loud, please.
No, wait till later.
That's the standard procedure for
No.
notes in class.
Okay, yeah, it's not. All right, let's go to the next one. Next problem here, let's go to the difference of squares route. So these are the problems that we were looking at earlier.
Oh, God.
That is big.
Grandma Dustin.
It's from handball. All right, never mind.
Who's it from?
Sabrina Hoover. She called us all handball and then.
How'd she call it handball?
I don't know, it was some inside joke. Yeah, you had to be there. You missed it. So.
Were you inside or were you outside?
I was present for it, still didn't understand it. All right, okay. All right, difference of squares. I want those 2 problems we had on the board earlier when we did those difference of squares. Does anyone still need these problems on the board though? Okay, let's do the first one. I don't know what that first problem was. I want that one again.
128.
Okay, keep going. Okay. Okay, so what we did is we took out a common factor of a 2 and an x. This turned out to be 64x squared minus 25. All right, because we took out a 2 and an x from everything. All right, now, the reason why I brought this problem back up, the part in the parenthesis part in the parenthesis is a difference of squares. It is. You can see it. They're perfect squares. Okay, so that check number 1, they're perfect squares, and there's a difference between them. Check number 2. Has to be a binomial, they keep going. So the 2x out front, you just leave it be. I don't really care about B. But the parenthesis behind will split up even further. So for the rules for difference of squares, how you do this, it's going to be plus minus automatically. The reason why it's a plus minus sign, it is actually following the trinomial rule because the back symbol is a negative, so it's automatically plus minus. Now, to break up the 64x squared and to do this, just get the square root of it. What's the square root of 64? 8, so you go 8x and 8x. What's the square root of 25? 5 and 5. You literally just take the square root and there's your numbers. That's it. You're done. You move on to the next one. Difference of squares is easy. The problem is on this problem, you had to, the start of the problem you had a common factor, but then you had to recognize that it was a difference of squares to go further. Difference of squares has to be a binomial and it has to be perfect squares being subtracted. Now, I want that second problem that I brought up.
That one would be 12x squared minus 4.
12x squared
To the 2.
minus 4. Okay.
To the 2.
To the 2.
Okay. So here's this next one. We took out a common factor in this particular problem. We took out a 4 first. So that was 3x squared minus 1. Now, when you looked at it, okay, it appears that it is a binomial, that is a difference. So it looks like it's a perfect square. So, what's the problem? What is it?
They're not squares.
Yeah, this first number isn't a square. It's not a perfect square. 1 is. 1 times 1 is 1. But 3 isn't. So technically, it fails the square part. But here's the weird thing. You can still factor it using difference of squares. The reason why you can keep going is because the variable is a perfect square and it is a difference. So how you do this, even though it's not a perfect square, we cheated a little bit. So you go 2 parentheses, so I'm going to leave the 4 out front. You go 2 parentheses, and we treat it like it is a perfect square. So you go plus minus, you take the square root of the 1s, that's 1 and 1, so that's easy, that is a perfect square number. And then for the 3x squared, you take the square root of that. What's the square root of 3? It's root 3, right? We can't even simplify it. It's a weird decimal like 1.7. But you just leave it this. Leave it square root of 3 and just put an x behind it. Square root of 3 and put an x behind it. Because when you actually multiply square root of 3's together, it does give you a whole number. It cancels out the radicals. So that's a way of cheating it. The reason why I bring that problem up, I know when I took the ACT, that was one of the questions. They wanted you to factor, to refresh your memory on Algebra 2 to see where you're at, but they would give you numbers that weren't perfect squares, and then wanted to see if you knew that little rule, where you could just take the square root of them, and that's how you do
Do you
it.
just remember every question you have on the ACT?
I remember most of the math ones, yeah.
Can you write them down for me?
I almost got it. I got a 10. We got a pretty good memory for math, Brown.
36.
Is it photographic board?
No, it's not. No, it's not photographic. It's just something I just kind of remember. Just okay. All right. Are we good so far? I don't think it's perfect photographic. I don't think anyone really has that.
Yeah.
Savants, I guess. All right. Moving on to the next one. So that was the different squares, easiest thing in the world. I just wanted to show you that little shortcut in case you don't have perfect squares. All right. Cube rule. This is the one we did yesterday. Cube rule. Okay. We only have 2 examples left. That's all I want to do. Okay. So, a cube rule. Does anyone still need these examples? No. Everyone's good? Okay. All right. For a cube rule, these numbers have to be cubic unless you want to do that little thing where you cheat the system and you do a weird square root or cube root. But I'm going to give you nice cube numbers. So let's go with 27 x to the 6 minus, let's go minus 9 today. And let's go with 216 I can put anything I want in there as long as it is a cube number. Cube numbers are 1, 8, 27, 64, 125, 216, 343, blah, blah, blah. Those are the cubic numbers I memorized. All right. Now, for cube numbers to work, they have to be cubic numbers or something you can take a cube root of. Their plus or minus doesn't matter because the cube rule doesn't say difference or sum, so it could be a plus or minus, doesn't matter. But the variables have to be multiples of 3. That's how you know if it's really a cube rule or not. This is a multiple of 3, so you can do a cube rule. It almost looks like it's a difference of squares. And that's the goofy part. I could actually attempt this problem using a difference of squares. The answer would look significantly different, but it would actually still work. That's the weird part about having a cube rule. There's certain ones, like this example I provide you, I could do it as a difference of squares because the x, even though it's a multiple of 3, it is a perfect square. It's an even number.
Ooh.
So, but anyways, I'm going to do it by the cube rule because that's the one that most people probably are familiar with. Okay, small parenthesis, large parenthesis. The first parenthesis is a binomial. It is the most important thing you need to find. If you can get the first parenthesis, you'll get the rest of the problem right. Okay, so the first parenthesis is everything. So in the first parenthesis, what symbol should I be using? Plus or minus sign?
Minus.
A minus. Why do we know that?
There's a minus sign.
There's a negative sign and there is no problem. This symbol literally transfers down to there. How do you know? We have a little acronym. It's called SOAP. This is a little acronym they print in almost every math book. Same symbol. The next symbol in the big parenthesis will be opposite for O. And then the back symbol will be always positive. Back symbol is always positive. Little SOAP acronym. Same, opposite, always positive. Now, in the first parenthesis, all you have to do is take the cube root of these. What is the cube root of 27? 3. And the cube root of x to the 6 is x squared. So 3x squared. How I get variables, just divide their power by 3. That's just how you get it. So if you have variables, if it's a multiple of 3, just divide it by 3. That's how you do it. Okay, 216, what number multiplies on itself?
Ooh.
6. Now, I could have taken out a common factor. They did have 3s. I didn't want to do that. All right, let's move on to the back. To get to the back parenthesis, this is how the cube rule always works. You are using these two numbers to make everything in the back. That's why the first parenthesis is the most important. So to get the back, the first item that goes here is the first item squared. So if I square a 3, what do I get? 3 squared. I get a 9. And x squared, if I square that, x to the 4th. So you square it. The middle term is made from both of these multiplied together. What's 6 times 3? 18x squared. Don't worry about plus or minus signs, we already have those filled in. You don't need to worry about those. And then the last term is the back item squared. 6 squared. 36. Done. If you FOIL that all out, like you want to double check your answer to see if I did it right, FOIL out first, outer, and last, or distribute a bunch of times, you will eventually get to this because all these middle terms will start canceling each other out.
I got the square root of 3 to 6 zeros. Okay, I'm hitting a stump now. I don't know if I can get it.
Square root of 3 to 6 zeros, wait a time.
1.73251. I'm trying to figure out the square root of 3.
Why don't you just put,
Split square root of 3.
Yeah, but it's easier this way.
All right, moving on. All right, we're going to practice this probably more. This will probably be a problem that Mr. Graham will probably put on the board if you're here, obviously.
Yeah.
Now,
I don't want to keep.
moving on from that. Okay, that's a cube rule. You got to get the first parenthesis. If you have that, the rest of it falls into place as long as you follow my little rule. Okay, the last group. This is my last example of the day. I'm only going to do one example of this because it's one of those things like every problem changes. You just have to recognize it when the problem comes up. The problem that we're doing is called a grouping problem. This might be the one type they don't really teach in Algebra 2. It's kind of this weird rule, they just don't show it because it's not consistent enough to warrant a discussion on it. It's one of those things, you recognize it when it comes up, and that's pretty much about it. It's not consistent. So, here it is. Let's go with 8x squared plus 4. Let's make these both these and x squares. We're gonna go with a 2x plus, let's go with, what do I want to do? I want to go with maybe 6x plus, can we go 3? Let's go 3.
So you just put the 84 and the 6 and
Okay, what was that?
the 3. So you would just put the 84 and the 6 and the 3.
Okay, yeah, so how this works is, and this is why every problem is different, but yeah, when I first start this problem, I'll group the first two together and the back two. If that doesn't work, and I'll explain what I mean by working, if that doesn't work, then I'll mix and match. Maybe I'll move the 8 and 6 together and the 4 and 3 together. I'll try different combinations. Okay, so this may not work. I'm kind of making it on the fly. This is the hardest group to kind of make up a problem work. All right, what you do is you're going to do each problem here separately on its own. So we go through all the rules. So I follow these rules as I go through when you do grouping. I start at the top and I work my way down. So on this first one, what do they have in common?
4x squared.
4x squared. Okay, so I'm going to take out a 4x squared from just these two items, just this first two. So when I factor out a 4x squared, I'm left with a 2x plus 1. Because I factored out a 4 from each of those items, 4x. Does that make sense? Does that make sense? In the back, what do the back items have in common? A 3. So I'm going to factor out a 3. When I factor out a 3, I'm left with a 2x plus 1. Does everyone see the idea of what I did there? Now, if you did this right, or if you recognize it, when you get to this point after you've done those problems separately, and they could be anything, maybe there's common factors, maybe it was something else you recognize. Maybe it was a difference of squares right away. Who knows what it is? I just recognize they have common factors. Once you're here, there should be something that matches on both the front and the back item. So in the front and the back, what do these two things have in common?
2x plus 1.
2x plus 1. You're going to take the 2x plus 1 off of them. So imagine that you're taking the 2x plus 1 out of the back from both of these items. So that's gone. What's left when these parentheses disappear? 4x squared plus 3. That's your final answer. That's how you know you did it right. It usually comes down to two binomials being multiplied together. But it doesn't work every time. You might recognize that, oh my gosh, they have something in common.
Got 7.
Okay. The problem is it's not consistent enough to I can't tell you every problem will be the exact same format. It may not be different, it may not be common factors. Maybe this problem here was a difference of squares. So you separate into two parentheses. And then further past that you recognize they had something else in common. So that's something you need to recognize. You might need to mix and match. We're done for the day? That's it? So, just want to introduce that. I'll do some more examples if you're here Monday. I'm Mr. Graham, I guess.